Okay, so anything in particular anyone wants to go over, or like, because like, anyone?
I'm honestly not even 100% sure what this exam is going to look like. So,
Well, in times like this, if I don't know what the exam is going to look like,
yeah.
I,
I,
I
I know he said he was going to be only on the lectures. So, I don't know if we should just like go
okay,
through.
so it's only on the lectures.
Yeah, he said we didn't have to like know anything about R or anything for the
Did he say,
exam. He
did
said it
he
was
say-
like,
Oh, sorry. Continue.
yeah, he said it was just like lectures only.
Okay. What What about the reading? Did he say anything about that?
I don't think anyone asked him about that.
Okay. All
Um,
right. Okay. Hey, Michelle. Glad you could join us.
Hi, I'm actually about to leave in like 2 minutes. I just wanted to see what was going on and make sure it was being recorded. But is there anything that I can help with in the short amount of time I can be here?
Yeah. Sorry about the delay. I kind of got I some I got held up with something that I honestly didn't think was going to take long, but ended up taking a lot longer than I thought it would. But yeah. Anyway, we should probably get started. I think the lecture whole thing kind of started with the scientific method. So basically, the observations, the questions. Did he? I remember he in one of his lectures he kind of delve into like differentiating between hypotheses and theories, right?
yeah.
All right, I'll just go ahead and note that down. Like, so basically, like, I think it was talking when people say I have a theory, they technically may not have a hypothesis. So hypotheses are could be guesses. Theories are like accepted educated guesses. Anyone want to add in? Uh,
Yeah, theories are usually hypotheses that have been tested multiple times already.
Yeah. And then like from the quiz, it said like like the answer was hypothesis and the question was like a description of how something in the world works. But yes, I must leave now. Thank you for having me. Have a great study session.
hey, glad you could join us, Michelle. We need all the people we can get, especially with this first exam showing up within the first 2 weeks of the semester.
Yeah, I think it should be fine. It's like pretty simple stuff. But yeah, if you're still going by the time my other thing ends, I will come back. But yes, goodbye.
Bye.
All right, I think there's some chit chat going on. Proven true. Oh, yeah, yes. Thanks, Amber. Um, theory, um, and then hypothesis tests the what. Questions ask the what and the why. Hypothesis questions are essential. Hypothesis leads to predictions, and then we have that route testing or experimental additional info, um, testing hypotheses. Test test doesn't support, you go back to it, and then of course we have the statement correlation does not equal causation. um oh just want to be sure everyone understand this part, the right here where I'm pointing to. uh the what versus the why, and then leads to association and cause effect. Here, let me just. You guys can see it, or
It's kind of hard to make out.
I can't really.
sorry. Let me know if it's not.
Yeah, what was your question?
You guys understand? There was this other. No, it's just there was this one thing that I just wanted to be sure I I wanted to have understood. Oh, Amber, it's not on my. It's not on my phone. It's on my laptop. So, that's why it's a little difficult. You know what? Hang on. I'm just gonna try something. It might take a while, but just give it a sec. I'll be as quick as I can. It's all right. I sent it to the group me. Let me know if you guys get it.
Oh, nice.
Oh, Hey, can you guys hear me?
Yeah.
Amber, what's
All
up?
right, cool. Hopefully none of my animals will start sounding off and my house won't get super loud.
Oh, you got pets at home?
Yeah. So, but I know he was talking about constructing a testable hypothesis. Don't be like too out there with it. I have a note in here about parametric models.
Mm-hmm.
I don't know if you guys caught that one.
Models, hold
Using
on.
data.
Parametric models, like parametric, like parameters, right?
Mm-hmm. Yeah, but it's using data and characterizing uncertainty.
I think I had that noted down somewhere. Hang on.
Okay, I just want to make yeah. It's like let's all make sure we have like similar notes.
Yeah, parameters. He was talking about like something about having more parameters, the more efficient your experiment might be, likely.
Mm-hmm. See, I have a feeling he's going to give us almost like scenarios, like he did, and then kind of be like, okay, use all your vocabulary to describe this scenario or whatever. Because I don't know. It just sounds like it's going to be really easy, but it's going to stress us out.
Did he talk at all about how the exam was going to be structured? Do you remember?
It's going to be a little bit of everything. I think there's going to be some multiple choice and like fill in the blanks kind of stuff.
Okay.
I think it's going to be kind of similar to his quizzes. And that's the thing that worries me because his quizzes are kind of awkward.
His quizzes
Yeah.
are not written great.
No. It's I would almost want to ask him if he could have his TA write them just so it's English is all there. It's like, what'd you just say?
Oh boy.
I don't know.
Models to test your hypothesis. It's about condensing information. You've got static and dynamic.
Oh, how good are you guys at like identifying independent variables and dependent variables in like certain scenarios? Because like honestly, that seems to get me every single time.
Dude, me too.
If I remember correctly, the dependent variables are the ones whose like results depend on something else. So, oh my God, it's always like I always get it like mixed up, especially since I haven't done like experiments in years. But You know what? I got my laptop here. I'm just gonna Google it real quick.
And science projects were a pain back in my day.
Yeah, but that's the thing is we're going to have to be able to figure out what is the dependent versus what is the independent if he gives us a scenario.
Okay, so according to Google, the independent variable is the cause, and the dependent variable is the effect, if that's how you want to look at it.
So something like this happens, therefore the dependent variable is the result, is what you're saying. Yeah. Yeah, basically,
Yeah. So like for the independent variable, the value is independent of other variables. So no matter what happens with the other variables, the independent should not be affected. So for the dependent, the value changes depending on the independent variable.
So, all right, shouldn't be too bad. Okay.
X doesn't change, but when X happens, Y happens.
Yes.
Mm-hmm. Yeah. All right. What else is there?
Prediction versus explain. What did I do? Amount, something for a model. I don't know. Discrete, continuous, categorical.
Ooh, I get this messed up.
Okay. Discrete is a specific number. There's no decimal.
Okay.
It's like counts. Like
yeah.
if you're doing bird counts or something, you don't have half a bird.
Yeah. Okay.
So that's discrete.
And
Continuous, decimal points, pi.
Yeah, complex numbers.
Mm-hmm.
Okay.
Well,
Category.
Sorry, yeah. Where are you at?
I don't know. It's somewhere below static and dynamic.
Static and dynamic. All right.
Yeah, just go below that, and I just kind of was going down my notes, hitting topics.
Static, dynamic. Oh, there it is. Data types. Just continuous.
Yeah,
or,
types of
continuous
yeah.
are like basically are like are decimal numbers. Discrete is whole numbers. Categorical then has a category in and of itself. Binaries are, you were talking about like binary. He mentioned something about absence expression.
I don't have that. Absent. All right, cool. He goes so fast. I'm glad you caught that.
And then ordered is like I guess categorical. It small, like for example, small, medium,
right.
large. And then nomial is numbers.
And categorical, you also have yes, no.
And then there's zero and not applicable for results that are for experiments where you get that sort of type thing. And then we have data structures, which are vectors, like V and 1, 2, 3 sitting on top of each other.
I have stuff before that in my notes.
Really?
Just a general going over the nomadic problem of big N equaling little n over P.
Huh. Wait a second. I think I had that somewhere too. Hang on.
Because he really harped on making sure you kind of understood how things would increase and decrease. I mean, it's knowing math, but.
Oh yeah, like that's under the what to do category. Under consider the following equation: big N equals n little n over little p. So increase.
And know what each one means. Number of what's big N.
Not like population.
No. The number of it's the number in the population. It's the number of the animals that are like out there.
Was it big N that's the population or little n?
Big N.
Okay, so big N was the number in the population.
Yep.
Yeah.
Little n was the number of animals detected by the observer, and p was the detection probability.
Yes.
Yeah.
And then just basically, I have myself like very specific notes because my brain always hates doing these. What makes n increase small p, or sorry, big N increase is a small p.
So
What makes big N decrease large p. So basically knowing what you're doing with your denominator.
if the detection probability is larger than the number of animals detected, then n is going to be small, and vice versa.
Mm-hmm. Yeah, just make sure you're able to go over those interpretations of that.
You increase n, if you increase little n, you increase big N, and vice versa. Yeah. That's what I had meant. And
then you've got n equaling 0 and p equaling 0.
wait.
Make sure you know what big N equals 0, little n equaling 0, and p equaling 0.
Wait, if p is 0, then anything you divide by 0 is undefined.
Right. I know, it's super, super elementary. I just have it written down as like, just make sure you understand that it doesn't get like something weird.
Yeah, got it.
Oh yeah, and then he has the vector stuff. I think what he's going to want us to know more on that is not necessarily how it relates to p, but how it relates to that equation of the sum of I equaling whatever I wants to equal, and then the subscript of, I don't think he's going to use w, he may use something different, but with the subscript I, because he's probably going to give us something that's like, w1 times w2 in parentheses, a whole bunch of confusing stuff, because this class supposedly gets pretty intense with like almost like calculus kind of stuff.
That's what I'm worried about.
That's where these W equations come in. So I have a feeling he's really going to make sure that we are solid with plugging numbers into where I's and W's and stuff are.
Mm-hmm.
And knowing how many of them you have, where that subscript, upper script thing 3 is, meaning, there's this many of them, and knowing to be able to take that equation apart.
But right now, let's just focus. But right now, we're just focusing, like, we're not in that right now. So I know that's gonna come further down the road, but
yeah, no, I'm saying for this test, he may ask us just something very simple, just to make sure that we're following that this is the way it's going to go. So don't discount it as a possibility for the test. And then I don't know why I made a big deal about writing down that weird, it's not a pi symbol, it's almost like a little tower.
Oh, I know what you're talking multiply.
About. Yeah, because I've never seen it before.
Wait a second, I think I know what you're talking about. Hang on.
He talked about it in the first class.
Mm-hmm.
I don't remember what it's called.
No, me neither. But it was something weird.
Oh, it looked like a Roman numeral 2, but it didn't have that line that went through it.
Right.
It was this one, no?
Yep. Yeah.
Yeah. So yeah,
just recognize it.
It doesn't really mean pi so much as it is a multiplication symbol. It's just a big fan.
Oh yeah. No, I said it kind of looks like the pi one, but it's not it. Yeah, then I'm hoping that honestly the whole thing's going to be more experimental design, but I'm glad we went over that and made sure that we at least have the first half of the class that the notes are all similar.
So, and then we have that summation symbol where we just, I guess, just multiply. I just want to.
Yeah, that's what I'm talking about. That submission symbol, that weird funky E.
Yeah.
Make sure you can pull that all apart and you know what all the parts and pieces are and what it means.
Yeah, like I even tried giving a whack at it myself. I'm gonna send another. I'm gonna send another group me because I just want to show you what I did. The one in pencil was my first attempt. The one in pen is the actual correction. So let me just send that to group me that way you can see what I did. Oh, hang on.
I'm not following. Oh, your notes.
All right. So did anyone get the summation photo I sent on GroupMe?
Yeah.
All right. So you can kind of see where I went wrong. So it's actually like multiplying like the numbers individually depending on how it's set up. Huh. Laura, I like your
Oh,
picture
okay.
I like your picture with the sloth.
Oh, thank you.
Where was that?
It's at my internship in Miami.
Ah, it's really nice. Quick question. Does anyone understand the miscellaneous portion of it, of this, of the one after the summation exercise? There are all these symbols and numbers. I just want to be sure I understand what they're getting at here.
I don't have my notes on me because I'm at work, so I'm not sure what you're referring to.
Yeah. I put it in group me.
Okay. Oh yeah, I do not know what any of those symbols mean.
Oh, never mind. It even says in here that reverse number 3 is in. The
okay.
down A is for all. Sorry for asking that. Okay, so I guess in the example is, what in the examples it's 10 in S. Si is greater than or equal to 10 for all Si in S, and then Y is in between 0 and 1, which is equal to Y I notation equals 0 or 1. Yi equals real value, and then the squiggly equal sign is approximately equal to. Okay, that makes a little more sense, I guess. And then he went into a little bit on logs, so like how log is just basically saying 10 to the 100th power or whatever. Basically log 10 of 100 is equal to 10x equals 100. What is x basically? Crap. Crap. it is. All right, and now you guys are good on logs. I mean, logarithms.
Oh,
He kind of talked a little bit on that.
yeah.
I mean, of course, I don't really have my graphing calculator for this. I honestly have my Texas Instruments. He did say we don't really need one, but like, I don't know. I guess with all these calculations, might as well. Oh, I have at least something anyway. He said it's not required. It's just
Yeah.
you guys get these graphs though, right? These ones.
I think so.
You understand where he was going with it at the time?
Can you give me like a quick refresher?
Honestly, I don't recall. I wish I could. And then he went. What about statistical notation? Anyone confused or? I mean, I know he has like everything noted down here, but like, um, is anyone having an issue?
I think I'm good.
All right. So the micrometers, population mean, O squared, population variance, and population size. Oh, now that I think about it, it might. I'm just trying to think of ways he might like try and make us apply those symbols. Now that I think about it, not sure if. What do you think?
I'm sorry, what?
You know the statistical notation that he has: population mean, population variance, and population size, and everything else
Yeah.
under that. I was just trying to think of ways that he might make us try and incorporate that, but like nothing comes to mind for.
I mean, I honestly don't know. I definitely think we should know what each symbol means, but just in regards to that, if he does throw like any kind of equation or logic problem at us, we can actually read what's in front of us. But other than that, I really don't know.
I just thought I'd ask. And then population group of organisms, same species, occupying the same space simultaneously. Many populations of population within a population. We all get that. Parasitism occurs. Species diversity also plays a part in population. And then I couldn't get this down considering he was moving a little quick. He said something about habitat and landscape. Did anyone know anything for that?
Is that from lecture 3?
If he's talking about habitat and landscape, then he just wants you to know that it's heterogeneic. Blah blah. I can never pronounce that word. Just know that it's hetero.
Oh,
Okay.
oh,
Yeah, landscape is hetero. That's all.
Okay.
Heterogeneic. Blah, blah, blah.
There you go. You got it.
There you go.
heterogeneous. Oh, yeah, habitat is basically organisms live. Like resources and conditions in the area affect species specific. And then experimental unit. The smallest system of the experimental material where single treatment assigned and dealt with independently. So basically, I'm not sure what you guys got out of that one, but for that one, I just thought I'd show you. I just basically drew what he had on the
Oh, okay.
If you guys have anything to add as far as this is concerned, let me know.
Such a complicated definition.
What was that, Laura?
No, it's just a complicated definition.
Uh, and then,
The types of studies.
oh yeah, descriptive, the studies that give description of the interest, system of interest. Mensurative, observational studies where researchers suspects conditions apply, measure what exists. Manipulative, observational and ecological system of interest under specific controllable circumstances.
Yeah.
Got it.
The 4 key aspects: replication, control, randomization, and independence.
Wait a second, I think I had that. Yeah, randomization, independent, no. Replication, control, randomization, independence. The key characteristics. And then he went into the types of designs on slide 17 of the last lecture we went over. I talked to him today about it. I believe it was competitive of randomization, where it's like where the subjects are randomized in space. And then there's random blocks, which is like where there's like one treatment area and then one control. I kind of think of it. I should probably have.
I'm looking at the slides now. There's completely randomized block, systematic, simple segregation, clump segregation, isolative segregation, randomized but with interdependent replicates, and no replication.
Yeah, randomized blocks where one treatment is paired with one control. Then systemic is like pattern system placed on.
Yeah.
Simple segregation, equal amounts of control and treatments. Clump segregation, equal amounts of control and treatment, just isolated. Isolated segregation is basically when you put them in the box. I think randomized but interdependent replicates is what's going to get me a little bit.
Yeah.
Like I was talking to the professor about it. At first, I like when we were talking about like plants in an experiment, I thought he meant like at first I thought he meant like he meant water gained from us when we watered them versus the other plants getting watered from the rain. But honestly, the only thing I was able to get out of that was that it's the plants are given water from the same source, and it's one of those dependency issues sort of deal. I honestly don't know. I'm just trying to I'm doing the best I can to get the details of it. So if anyone's got a better explanation, I'm open to suggestions.
Honestly, it just looks like randomized but with interdependent replicates would just be whatever the most complicated answer is, because all the other ones are pretty straightforward. Let me see if Google has a more simplified.
I'm sorry, I just got here, guys. What exactly are we talking about?
Hey, Garrett, how's it going?
Hey, Darnish. It's not too bad.
How do you feel about the exam tomorrow?
I'm kind of in the fuck it attitude. It's the first quiz, so I'm gonna basically judge it on like how much focus I need to put into the rest of this class.
Well, we just covered just about everything from the first lecture up to now. We just got onto types of designs. Yeah, is there anything that you want to discuss that you think might be a little challenging, or?
No, not really. Just kind of popping in here, see what y'all are up to.
Yeah, we were just trying to review for the exam. We kind of have reason to worry, or at least I do anyway.
Yeah. Was there a specific thing we were looking over? Or was there like a guide that he sent out or anything?
No, we're kind of just going through lecture stuff.
Yeah, I mean, as far as I know, I emailed the professor this evening as to whether or not he's also going to test us on the readings, but still I'm not. It's a little late, so I'm probably not going to get a response until tomorrow morning.
Yeah, I emailed him too to ask if we were gonna have to be concerned about the readings as well.
So it does say on I think both the module pages for like week 1 and week 2 that Hillborn is going to be on the exam. So.
Yeah. So why notation I distributed? Hey Garrett,
Yeah.
you know that logarithm slide that he was talking about? One of the slides he was talking, one of the lectures he was talking about logarithms.
I'm not sure. Was that for week 2 or week 1?
That should have been for that I believe was week 1, I believe.
Mhm.
So let me just check.
To be honest, I don't remember anything about logarithmic functions. So I might be in a little trouble, but we'll find out tomorrow.
Well, it's only 21 questions.
Yeah.
21 questions. That's
We have about an hour to complete it.
yeah.
That's gonna be fine. It's mostly like a lot of like theoretical questions that I think are gonna be on it. I don't think there's gonna be a whole lot of like math questions. Hopefully not. I haven't taken a math class in a while.
Last time I took a math class was 2018.
Yeah. So, for example, I don't see any logarithmic functions on any of his slides.
Sean, are you talking about the like his
I,
like?
I have it on my. Oh, sorry, Danny. Did you want to say something?
Are you talking about his little like log review like slide?
Yeah, like I have it right here.
Right.
Yeah, it's number slide 27 on lecture 2.
Okay.
There it is.
It's basically like log 10 of, and then x is just however many zeros you're adding to 10.
Mm-hmm.
I think he's like just trying to show you that like you can use logs to like mess around with data. I don't know. I don't really think it's like a whole lot of stuff.
Sorry, did you say something? What was that, Danny?
I don't think he's like trying to like say anything like particularly deep with that slide. I think he's just like, hey, remember that logs exist? Like you can use them to like manipulate data. All right, cool.
I don't even think. I think it was just kind of like a refresher to like what we're going to be getting into like later in the semester.
Yeah, because like a log transformation of data is like a really common thing in like monitoring and management stuff.
Mm-hmm.
Mm.
Hopefully, it's just going to be like a lot of experimental design questions.
Mhm.
And be like, is this a good experimental design? What's wrong with this? You know? And I don't know. It's
And then there's like, I guess, and I guess you're good on like the whole differentiating between independent variables and dependent variables, Garrett.
um I know like abiotic factors are independent. Like you can't really like. Yeah, I'm fairly confident with that. I would say.
All right, but like if you were to give you a certain scenario, you'd be able to identify them.
Yeah, I believe so.
All right, so I'll go ahead. And you said abiotic factors are typically independent, you said?
Yeah, because they're typically independent.
What? Any reason you think that? Or
Uh, because uh, it's just what I remember from my other classes. I can't really.
Usually, like if you're looking at I don't know, like the level of oxygen in the water, that's independent because like water is just doing its thing. You can't really change it. Or like temperature is independent, like nothing to do with that.
Mm-hmm.
it's not changeable.
Did we even go over independent or dependent variables?
Not really.
Okay. I was just curious if I already asked, but he didn't put out a guide or anything for this exam. Just the past lecture videos.
Yeah.
Yeah.
Yeah, I don't know. I don't think it's gonna be like super hard, but
I don't think so either.
I don't want to. I mean, I don't. So far, I'm like really close to getting a B in the class, but like I'm like at a low A right now, so I'm.
At least the exams aren't worth a huge percentage of our grade.
Yeah, that is the saving grace.
Still, it's no time to. That's not going to be our saving net forever.
Yeah.
We still gotta pull our weight.
True or false, Darnesh? Are all models wrong?
They're not wrong, but not all of them are useful.
That is incorrect. All models are wrong on some part. There's
Yeah.
not fully correct models.
Wait, hang on. There wasn't what? Hang on. There was a quote on that. Hang on.
Mm-hmm. Uh, lecture 2 of the first week, slide 12. Can anybody explain to me what static versus dynamic models are?
dynamic models are meant to accommodate change.
Okay. And I'm guessing static models don't accommodate change?
Yeah, so a static model is looking at like data you take in a specific point in time, and a dynamic model is usually the kind they use to like make predictions.
Yeah.
All models are wrong, but some are useful.
Mm-hmm.
Yeah.
Not oh. That's what it was. And and going back to what you were saying, you guys were saying something about dynamic and static models, you said?
Mm-hmm.
One let me just okay, the types of models: deterministic versus stochastic, and then analytical versus computational, static versus dynamic, temporal wise dynamic models. So so you guys, so static ones are, what'd you say worst? Sorry, I kind of got hung up on the models quote. Could you guys say that again?
Yeah, so dynamic models are meant to accommodate change. Usually those are ones that like will look at time, because you're meant to look at like this like really wide scale thing. And static models are like models based on data taken within like a certain subset of time, and they're usually not used for predictions, and they don't change.
Taken within set time and don't change. The variables don't change in static. The variables often don't change, right? You said in static mode.
I mean, if that's like how thinking about it works for you, yeah.
All right. I just wanted to be sure because, like, I guess I just.
Have you ever taken a class of modeling before, or
Sorry, say that again.
have you ever taken like a modeling class before or no?
The last time I did that, I took a modeling class. If by modeling class you mean like statistics, then
Mhm.
that was like last time I did it was 2016. That was like what 4 or 5 years ago now. That's like
Okay.
yeah.
So yeah, okay. I guess so for the most part, static models are like based on like the time period within which you took the data. They're not really usually used to predict things because you have to incorporate other things if you want to make predictions. So like if, for example, you ran some study like winter of this year and you made a static model out of it, that model would be used to discuss like things within like winter of this year, you know? Whereas if you made like a dynamic model for that, it would probably involve like more complicated shit, but you could use it to predict like, oh, what happens next year based on this. Does that make sense?
So making predictions based on the evidence you have, I guess.
Like a static model is just more valid for like a certain time period, and a dynamic model like incorporates time change.
Yeah. Yeah. So basically dynamic models are more adaptable than static models at a certain time.
Not necessarily more adaptable because you know you can build your models whatever you want. I would say more,
Accommodating for time.
yeah, more able to be generalized, I guess.
Yeah. And then did he go over deterministic versus stochastic?
Not yet.
Oh. Analytical versus computational?
Not yet.
All right, I guess.
I guess I'm gonna go. I'm gonna go head out. I'm gonna go make dinner. Good luck on tomorrow's exam.
All right.
Sorry, couldn't be more help, or be here longer. So see you.
There you go.
Hey, you're of good help, man. So I think I already left.
So sure. Okay. There's this lecture that I have from an old class. I'll drop it here for you. If I can, Zoom will let me. Let's see. Okay, annoying. Can I share my screen or is it disabled?
Hold that thought.
Mhm.
Okay. Let me just go to you. Wait, how did I do this before? All right. So. I think it was. Ah, there it is. All right, so
Okay, so this is an old lecture, which may or may not be helpful to you. Give me 1 second. Let me go back to it. Did I close it? Hold on. Okay, so that's the definition between deterministic and stochastic, but like it basically is just like stochastic models have like an element of randomness.
Yeah.
So if you were going to model something like in natural sciences, it's most likely going to be a stochastic model because like, you know, nature is fucky.
so stochastic.
Stochastic.
So
As for shit happens.
Hell yeah.
yeah. Okay. Yeah. So basically, stochastic models where random stuff happens. So an example of that would probably be you were saying, Danny, you were saying something about nature being.
I mean, yeah, like whatever model you create, like as long as you're like looking at animals or plants or something, there's always some element of randomness and like genetic diversity and behavior and like literally like anything. Like you can't predict everything that's going to happen because the planet just throws weird shit at you.
Right. And then deterministic models, that one, output of the model is fully determined.
Yeah, which usually applies to more like pure math stuff. Or like if you're working with like hypothetical numbers or if randomness is just not something you think about. Yeah, that's it. And then I'm not entirely sure of like what his difference between an analytical versus a computational model is.
Got that up. I got that pulled up right now. According to this quick internet search, it says a computational model is a mathematical model in computational science that requires extensive computational resources to study behavior of a complex system by computer or simulation. So basically, you're studying science. You're doing scientific studies using computational and computer resources.
I mean, yeah, but you can. I don't know. I'm like hoping he doesn't like pull like random definitions out his ass and be like, define this exactly how I said it or it's wrong. But he doesn't seem like that kind of professor, so I think we're good.
Well, with no study guide and with little to no practice questions to go off on, I'm just doing everything I can to be prepared for any possible curveball you might throw at us,
That's fair.
even if it might not be much.
I'm gonna go because I have to actually read the Hilborn paper because I didn't do that when he said we were supposed to. So I will see y'all, I guess, like in class on Thursday.
You have to go somewhere?
Hmm?
You have to go somewhere?
No, I just want to do this reading and like play like annoying music, and like I'm not gonna do that on Zoom.
All right.
But
Yeah, I have to get back to work because unfortunately I am on shift right now
Where you work?
at the Rights.
Oh, nice. All right. Well, see
Well,
y'all. Godspeed tomorrow.
Good luck.
Last 4 hours, so you know, like this.
Oh, well, I hope this helps. I'll go ahead and